It's called Collecting More and Less, Data and Specimens in Ecology. I had AIDS research in the title originally, and I just had to cut down. I'm supposed to do 25 minutes, and we're supposed to have lots of time for discussion, so I had to tighten it up a little bit, which means we'll go fast through some things, but I'll still try to explain as much as I can. Let me just give you the outline, sort of like what I want to talk about. And it's kind of a reaction actually to maybe the general discourse that we have about the relationship of data to the planet, and then maybe even to some of the framings that I got in the from the invitation for this talk. One thing I'm sort of chafing against and reacting against is an idea that sort of data and specimens, or data in general, are a cost to the planet. That every form of their preservation, every time that we try to keep one, a datum, a little specimen of frozen blood, it is a kind of cost to the planet. Another one that I think I'm going to be reacting to in this talk is sort of the opposite, and in the same way the same, where data and specimens, the preservation of them, leads directly to planetary sustainability. So I'm reacting to both of these. I'm sort of rejecting both of these across the talk, and I'm doing something messier. I'm moving in the direction of a symmetrical analysis, and saying instead, by the end, something much messier, which is this little, if the two top equations are what I'm rejecting, then the bottom equation, cost, labor, space, and parsimony, and ecological impact are all involved in the weighing of a potential planetary resource. So that's kind of what I'm going to walk you through. I'm going to do it in part through this paper that Estrid was suggesting, was sort of summarizing, but just like a tiny window into the paper. I just want to ground it a little bit in an empirical investigation so you have a sense of what I'm getting at. But this is the paper, and I just want to give also a little shout out then to my co-authors, Shana Hirsch and Sarah Inman, Shana really being the lead on this paper. I'm going to paint the paper in like the broadest strokes possible. It's really a study of this thing that you're seeing on the screen right now, which is the Long-Term Ecological Research Network, here represented as all the sites that they have across the United States. The paper is sort of based on a study of this, a long-term network that does support or is an infrastructure for ecological research. Think about each one of these sites, each one of those places where they have a place that they're investigating a little bit of ecology has something that looks like this. This being a room filled with specimens of water. In this case, they're just little vials of water that they've collected from rivers. And each one of these has like these like messy looking cold rooms where they put all these specimens of water. I know we're talking about data today, but I want you to also think about like each one of these specimens sort of also as a tax on the planet in some sense. It takes energy to keep them, but also each one of them is little vials that you're seeing in that picture that has a barcode. And every single one of those barcodes is linked to actually a humongous amount of data about each one of those specimens, where it was collected, what river it came from, who did the collection, what was the temperature of the river when that was collected. All of that is stored as data that is linked, tied, data and specimens to, and they all have to be preserved together. But anyways, let's keep moving along. What the paper does, what it kind of explores is a transition that has occurred in the field of ecology, ecological science, and broadly, and just in broad stroke, giving it to you, it tracks a movement of how ecologists went from thinking about sort of something we might call pristine nature. This formula here is one of the earliest ways of representing the question of how soil is formed. And what you can see is in this formula, all these are the things that they're considering when they're thinking about soil. And what we do in the papers is track a transition from this, the biogeophysical model, to something that starts sort of collating or congealing in the mid-1990s, which they call the socio-ecological model. And the socio-ecological model sort of differs really from the biogeophysical old model because it has anthropogenic elements involved. In other words, here we have a series of ecologists who are starting to think about the impacts of the human impacts on the formation of soil. And so they sort of, to do that, they need to move away from a model that just thought about natural elements, climate, organisms, parent materials, and also started thinking about anthropogenic features. That's really what the paper tracks, and all I've given you sort of is like the first 2 pages of the paper. So there's a lot of consequences here, a lot of exploration. The thing I want you to take away to understand for this talk is that when that transition occurred, when ecologists moved from thinking about sort of nature on its own, soil on its own, to a kind of socio-ecological, soil and humans together, a lot of what they did remained exactly the same, especially when it came to collecting data and specimens. That is, that like they didn't stop collecting dirt or samples of water or samples of organisms or taking temperature measurements. They still kept doing that stuff, but they also started adding other things, which they call anthropogenic, things like attitudes towards environment, things like practices of fertilizing the soil. So the transition, what I really want to emphasize here is all of this data that they'd been collecting for many, many decades, starting from the 1980s, but actually in some places longer. It's not like it went away when they started thinking something different. When they started thinking about socio-ecological soil, they didn't just throw out all of the things that they'd collected before, they repurposed those. Those became useful and new in the new model of science and the new model of thinking socio-ecologically. They sort of like rearranged those, and they did need to do different things. And these specimens did come to stand in for different things than they had before, and the data as well. But it was still them, it was still these materials that were being repurposed. And so these archives played a new role, even across a fairly dramatic transition. Okay, so let's get back to really like that's as empirical as I'm going to get in this talk, and I'll try to like re-say it again a few times if you didn't capture it. But this is kind of like an argumentative talk that I'm actually giving you. As I said, I'm sort of opposing this idea that these preservation of data and specimens are a direct cost to the planet. That should be a little clearer now why I would resist this, right? As though every time we preserve some data or every time we preserve a frozen bit of dirt, it's just an expense to the planet. It's just a use of energy. It's just taking away. It is just consuming. It is just a cost to the planet. You can see why I'm resisting that, because part of the story that I'm telling in the empirical narrative of these ecologists is that every data and specimen was also useful for rethinking the environment, for moving from a transition of thinking about pristine nature over there to thinking about how are we involved. Those old specimens, old data, old samples of water came to be repurposed in forming this new vision. Another way of saying that is the old data and specimens served a new role in us hearing what's going on with the planet, and us coming to understand what anthropogenic climate change might be. But I don't want to fall automatically into the other one, though. What I don't want to do then is turn this into a talk where I'm just saying sort of like data and specimens are the pathway to planetary sustainability. I don't want to just do the reverse and take the opposite stance, or what looks like the opposite stance, and just say, we need to preserve everything, because every possible amount of stored earth or stored water or stored temperature data about those water, every one of those is going to be great for the planet. That is how we're going to come to know. This would I think this would be coming closer to taking almost a traditional scientific view that we need to keep everything. And today it just would mean something like, you machine learn it, right? Like take all those data and specimens, shove them through some machine, analyze them, and that will like lead to a perfect understanding or better understanding of the planet. So we preserve everything. These two sort of like look like opposites, right? Like this one is valuing data and specimens as good. It is a kind of techno-solutionist approach. It is saying we need to keep all of it so we can do the scientific research. And it looks like the opposite over here. This is casting it the other way. Data and specimens are a danger to the planet, a techno-dystopian vision. Everything that we do, every time we preserve some form of data, it actually is a cost to the planet. What I really want to do, though, is say that I actually don't think that these are as different as they appear. Really, they're just two opposite sides of the same coin. And so this is where I'm going to draw in this imagery that comes out of originally from Bruno Latour's "We've Never Been Modern." This is one of the diagrams that appears in that book. And in general, sort of here, I'm inspired by material semiotics, about a symmetrical approach, many other people in that tradition. and who are sort of contesting and saying, like, it looks like these two things are different, but actually they're playing out the same thing again and again. And that is the distinction between nature and culture, the primary dichotomy, I think, that we've never been modern is sort of attacking. Unfortunately, this image that I'm drawing from directly from the book, it kind of drew things the opposite way. So we have to like look at it like this, right? So I didn't want to flip it on you because then the words wouldn't be readable. But really, so just to draw it out for you, note that on these sides of the equation, what you're seeing in both cases is nature. A cost to the planet or a planetary sustainability is placed over there. And then data and specimens are sort of considered, whether they're bad or good, they're both a kind of human thing. They're both a thing that we're up to in the world. They're both like an object of culture. And so both of these models actually share that in common. Both of them sort of frame a kind of either you're saying the data and specimens are this terrible human thing that we're doing and coming as a cost, they're draining the planet through the consumption of energy and resources, or they're going to save us, right? But really it comes to the same thing. And so that's why I want to show that bottom part of that diagram. This is sort of this is what's proposed in a kind of material semiotic or actor network approach in which instead you're looking at kinds of networks. The topology is flat. There's no great divide. It's a complex mix of the two in which you are reconfiguring the relationships. So what does that actually mean? What does that actually mean in practice? Well, as always, when you're doing like this kind of STS study, the answer is to go closer to the scientist, closer to the phenomena that you're looking at, get empirical. If you were to ask these ecologists, are you trying to keep everything? Is that what you're trying to do? Are you preserving every specimen that you can get your hands on, every bit of data that you can get a hold of, the temperature? I want you to think here about ecology. Ecology is such a heterogeneous science. They're interested in rivers, and they're also interested in worms. They're interested in birds and bees. They're interested in the atmosphere. They're interested in the nature of soil. They're interested in what's below the soil. They're interested in oceans. They're interested in deserts. They're interested in forests. There's a lot to be interested in ecology. And so if you were to ask them, like, are you keeping everything? Is that what you're doing? They would say, like, no, that is an impossibility. We are not keeping everything. In fact, we are having very intensive deliberations. And if you look through the empirical material of this research infrastructure between 1980 to the present, it is a continuous debate, sometimes amongst the archivists, sometimes amongst the scientists, sometimes amongst different kinds of scientists, the bird scientists versus the bee scientists versus the river scientists, all of them sort of debating out, what do we need to keep? What is important for the future? Kind of an understanding that it's absolutely impossible to keep everything. There's no such thing as keeping everything. The insides of research infrastructures or any kind of preservation endeavor is always already filled with enormous, vivid, very challenging, and often very political discussions about what to keep and not to keep. Here's how Bowker and Starr, in sorting things out, put it in 1999, what I'm saying to you. Who, by the way, when they wrote this, they were not yet at a communication school. They wrote this book while they were at an information school in Urbana-Champaign. So they were sort of very close to the question of archives at that point in time. The decision not to collect is the most difficult to take for people maintaining any sort of collection. There are always practical budget and storage issues. These are balanced against two other factors: the need for a well-ordered and in some sense parsimonious repository that can be used, and the side bets that are made about what material will be useful in the future. This latter is particularly difficult. Collectors and curators of all sorts must become future forecasters and decide the boundaries of what will be useful in the future. There's no perfect answer, only a set of practical trade-offs. What I'm going to do is sort of to continue the conversation as I have in the same way. I'm going to turn this like beautiful little paragraph into a horrible little equation, since everything's been equations. I don't think that Jeff and Lee would love that. Nevertheless, it's going to do work for me. Turning what they just said into an equation, it looks like something like this. The question of preserving data and specimens is always a matter of cost, labor, space, the parsimony of the archive, the accessibility of it, weighed against its potential as resources, something that will be useful later in the future. This is really what they're sort of saying in that paragraph. What I'm Well, here's the addition that I want to make to it. You can see those blank spaces, right? The thing that I want to like add to this conversation, the one I think that is useful for the conversation we're having in this series about the importance of data and specimens for planetary impact. On the one, I want to put on one side of the equation the ecological impact. What I mean by this is when I do talk to these ecologists or any other scientist who's preserving things, it's true that they're thinking about cost, labor, space, and parsimony, but they aren't usually thinking about ecological impact that is outside the range of what most scientists are thinking about when they're preserving a specimen or a datum. Even say, for example, these ecologists, I have never heard them talk about the preservation of a specimen as a matter of planetary impact, even though that's kind of what they think about. I've never heard them talk that way. But I think it's especially true with the other kinds of researchers that I work with. And then, so this is the addition that I want to make to it. We need to like weigh, along with the other things that are being weighed, whenever there's a question about data and specimens, we do need to weigh the ecological impact. But since I'm doing a symmetrical analysis, what I want to say is that I want to put that on the other side as well. I don't want to just put, the humans on one side and then the environment on the other. I want to put all the things on both sides. So in other words, it's not just potential resources. We need to think about them as potential planetary resources. What I mean by that is they might be the very things, these data and specimens need to be weighed in part for whether they're going to help us with the oncoming crisis that we're going to live through. Are they going to help us understand the planet? I could even go wider here. Are they going to help us convince other people? I want to put the weight of the decision making on both ends and say, we don't only think about cost, labor, and space and parsimony. We also think about the consequences for the planet when we preserve things. And when we're weighing their value, we're not just weighing them just as pure scientific resources. We're weighing what they might mean politically, what they might mean downstream for us, how they might help us understand what is going on in this emergent phenomena that we're calling anthropogenic climate change. So both of these need to be considered at the same time. Let me do like I'm going to switch authors altogether again. I'm going away from these terrible equations that I've been giving you, and instead I want to move towards someone who just again states what I'm saying, I think a little more elegantly. Oh wait, no, okay, yeah, I had this. I forgot about this. You can see that you're sort of drawing on Donna Haraway's terms. We could think about, instead of there being sort of on one side nature and culture, on one side it's nature, culture, planetary and resource, thinking about humans and the planet at the same time on the other end. Culture, nature, thinking simultaneously about our weights and decisions, our ideas, our values, and at the same time an ecological impact. So let me put it into a more elegant quote here, drawing on the work of William Connolly. He's a political philosopher who thinks a lot also, tries to incorporate the question of nature as he's trying to think about questions of human difference and survival as well. This is how he puts it. What is needed is a robust problematization of established realisms and idealisms through a political orientation that expresses reverence for life, attends to the fragility of the earth as a resource of human life, and struggles to draw political implications from this complex, appropriate to contemporary circumstances. This little phrasing does everything that my cold little equation did as well, in the sense that he's treating it as a political matter, and it's not a certain one. Notice again that it's a kind of weighing, and in the weighing are two things at the same time. There's the reverence for life, and then comma, the fragility of the earth is a human resource for human life. It is not one or the other. It isn't that over there we're putting the reverence for biological life on this planet, the state of the planet, and over here we're putting our interests and they're weighing against each other. They both have to be weighed in the same time, and it's a struggle. It's unclear exactly how this is going to be done. And it always has to be matched to the circumstance, the appropriate to the circumstances. So this is just a nicer way of putting this sort of raw equation that I put, and he's doing it more elegantly. But I think it is it's exactly the same kind of sentiment. Any sort of I think I have a kind of resistance then any time that we're putting one against the other, And we're saying it's a clean, tidy relationship, as the first two that I started with do. And instead of trying to create a kind of a messy space in which we have to negotiate, which is what politics is, where all the things are weighed at the same time, the humans and the natures together, but also the consequences for the humans and the nature on the other end as well. That's where I'm going to leave it. Thank you.